We are learning about solving quadratic equations by completing the square. So there's a lot of different ways that you can solve quadratic equations, but today we're completing the square. I know I've got this when I can write perfect square trinomials and solve quadratic equations by completing the square. So what does it mean to complete the square? I'll show you. We now look at a method for solving quadratics that involves a technique called completing the square. It involves creating a trinomial that is a perfect square, setting the factored trinomial equal to the constant, then using the square root property from the previous section. So let me show you how to do it. Number one, what constant term should be added to the following expressions to create a perfect square trinomial? So think back to what a perfect square trinomial is. You can write it as like a difference or sum of squares, okay? So this is what you do. You take the linear term, the negative 10, you divide that by 2, and then you square it, and you get 25. That's all you do. So for instance, if I wrote plus 25 here, that would create a perfect square trinomial. Okay, so let's try C, and then I'll let you do B. Okay, so if I divide the linear term by 2, and I square that, I'll get 49 over 4. So realize that I'm leaving this as an improper fraction, and that's okay. That's fine. All right, now that you've seen one of each, one with, an easy one, and that can be divided by 2, and one that can be divided by 2, let's try the middle one. Okay, so 16 divided by 2 is 8, and then you square it, and you get 64. All right, so you try these. Go ahead. Pause it. And you should get this. So this says complete the square for each expression and then factor the resulting perfect square. So we all can say, all right, obviously divide by 2 and square it, so I get plus 9. Divide by 2 and square it, so I get 25 over 4. Divide by 2, negative 1/2, and square it, you get positive 1/4. Now, so if we factor this, I know you can see it over here, but I'm just showing you how they're doing it. So, all right, if we remember so you're factoring perfect squares, right? So the square root of this sign, and the square root of the 9. Let's do another one. The square root of y squared, this sign, and the square root of 25 over 4. One more. The square root of that, this sign, and the square root of 1/4. That's how they're getting those. So solve any quadratic equation by completing the square. If the coefficient of x squared is 1, go to step 2. If not, divide both sides of the equation by the coefficient of x squared. Get all the terms with variables on one side and all the constants on the other side. Find half of the coefficient, so divide by 2 and square it, of the linear term. Add that number to both sides of the equation. Factor the resulting perfect square trinomial, and then use the square root property to solve. Remember, when you take the square root, you must put a positive and negative sign. It could be either positive or negative. So let's try this one. Sorry. Okay, so let's look at it first. My coefficient is a 1, so I'm good there. I have all my variables on the left and all my constants on the right. So I'm where I want to be. Now I'm going to take that 6, I'm going to divide it by 2, and square that, and I get 9. So that is completing the square. So I add that. Remember, if you add something to one side, you have to add it to the other, right? So I'm going to add the 9 to both sides of the equation. Now I'm going to factor this, right, like we did in the last example. So I take the square root of the y squared, this sign, and the square root of the 9. Negative 8 plus 9 is 1. Now I'm going to use the square root property to solve this. So I'm going to take the square root of both sides because I'm solving for the y. The square and the square root will cancel each other out. So I'll just get y plus 3 equals positive and negative 1. Then I'm going to subtract the 3 from both sides. So I have y equals negative 3 plus 1 and negative 3 minus 1. So negative 3 plus 1 is negative 2, and negative 3 minus 1 is negative 4. Now you always want to go back and make sure that none of these answers will give you a negative under a radical. Other than that, it should be good. To be. So solve by completing the square. So again, we're going to move this constant to the other side. Then you take your linear term, which is 1, divide it by 2, and square it, and you get 1/4. So I'm going to add 1/4 to both sides of the equation. I'm going to factor the left side. So I've got the square root of y squared, this sign, and the square root of 1/4, which is 1 over 2. And then you're going to add 7 and 1/4 together. So kind of like my scratch work over here. Okay, so 7, if I had to get like terms, that would be 28 over 4 plus 1 over 4. And again, I'm changing 7 over 1 to 28 over 4, so I can combine like terms. And we get 29 over 4. So that's kind of my scratch work for right there. Okay, now to solve for the y, I'm going to take the square root of both sides. So I've got y plus 1/2 equals positive and negative the square root of 29, and then the square root of 4 is 2. Notice how I took that out of the radical. So now all I have to do is subtract that 1/2 from both sides. Now you can't combine anything else because, well, you can't combine the 1 and the 29 because the 29 is a radicand and the 1 is not. But you can, if you want to, combine all the numerator together since you have the same denominator. And that's your final answer. Okay, you go ahead and do these. So pause the screen. I do want to say real quick, this right here, your very first thing that you would want to do is distribute that and move that 1 over to the other side. We can do this one together real quick, I guess. You know what? We'll save that one. If you want to try for it, go for it. And your answers are right there. Okay. Now I'm going to teach you how to solve completing the square when you do have that coefficient in front. So that last one that you did, that I started for you, this will help with that. Okay, so we can do this. Okay, so remember step 1, if the coefficient is x squared is 1, go to step 2. If not, divide both sides of the equation by the coefficient of x squared. So I'm just going to rewrite this again, and I'm going to move that 1 to the other side. Okay, now this is not a 1, so I have to divide everything in the whole equation by 2 to get rid of this coefficient. So I get x squared plus 7x equals 1/2. And now you're back to where you were, okay? So divide 7 by 2 and square it so you get 49 over 4. So I'm going to add that to both sides. And then I'm going to factor. So I get square root of x squared, this sign, and the square root of 49 over 4, which is 7 and 2. And then I'm going to combine these. So I have to change to a common denominator. So I'm going to change 2 over 4 plus 49 over 4, which would be 51 over 4. Take the square root of both sides. So I get x plus 7 over 2 equals positive and negative square root of 51 over 2, because the square root of 4 is 2. Now all I have to do, I'm going to kind of go over here. All I have to do is subtract that 7 over 2. So I'm going to go x equals negative 7 over 2 plus or minus that square root of 51. Now you can write it, whoops, sorry. You can write it x equals negative 7 over 2 plus or minus the square root of 51 over 2. But I think they want you to put it as an all-in-one if the denominators are the same. Okay, 3b. All right, so now you kind of got one that you have to do some work to. So let's start off by distributing. Okay, so I'm going to say 4x squared plus 10x equals negative 3. Now I need to get rid of that 4, right? So I have to divide everything by 4. And then I would simplify that to 5 over 2. Okay, now we're going to take the 5 over 2 and divide it by 2. What happens when you divide a fraction? You have to multiply that by the reciprocal, which would be 5 over 4. And then I'm going to square that, right? And it would be 25 over 16. So I'm going to add that to both sides. So 5 over 2 divided by 2 is 5 over 4. And then when I square that, I get 25 and 16. So I'm going to factor this. So the square root of x squared is x, this plus sign, and then 5 and 4. Now I need a common denominator, so it's going to be 16. So if I have to multiply this denominator by 4, I have to multiply that numerator by 4. And so I would get x plus 5 over 4 squared equals 13 over 16. Take the square root of both sides. I would get x plus 5 over 4 equals positive and negative square root of 13 all over 4. So I'm going to subtract that 5 over 4 from both sides. And since you have the same denominators, you can write it all together. Okay, you try these. Go ahead. Okay, here are your answers. I'm going to go ahead and do one of these with you. So let's see. I'll do E with you. How about that? Okay, so I want to get my variables on one side, my constants on the other, and I'm going to divide by that coefficient, the leading coefficient. So I get x squared minus 2/3 x equals 35 over 9, which is not pleasant. Now I'm going to take negative 2/3 and divide it by 2, which is the same thing as multiplying by 1/2. And now I get negative 1/3. Then I square that, and I get 1/9. So I'm going to add 1/9 to both sides. So when I do that, I get x minus 1/3 squared equals 36 over 9. When you take the square root, both of those are perfect squares. So I'd have x minus 1/3 equals positive and negative 6 over 3. Then I add the 1/3 to both sides. So 1 plus 6 is 7 over 3. And 1 minus 6 is negative 5 over 3. And that is how they got these kind of answers. I know I've got this when I can write perfect square trinomials, solve quadratic equations by completing the square. But do you really understand? So explain how to find the number that needs to be added to both sides of the equation, x squared minus 8x equals -2, in order to solve the equation by completing the square. So you divide it by 2 and square it. So half of 8 is -4, square root is 16. What is the first step in solving the equation 3x squared plus 12x plus 1 equals 0 by completing the square? Divide both sides of the equation by 3. Now, you could have said subtract the 1 and then divide the 3. It would be the same thing either way.